All right, today what we're going to be looking at is we're still going to be working with y equals sine x and y equals cos x. So in other words, the trig function graphs. However, what we're going to be looking at for our goals is I can apply transformations, and the transformations we're going to be looking at today are vertical displacements as well as amplitude changes to our sinusoidal functions. Now, just a really quick review from last lesson, okay? So this was the graph of sine x, and this is the graph of cos x. And one of the things that you should really know, and it should be in your head, is notice that the lowest, highest, middle points occur every 90 degrees. And that is true whether I have a sine graph or whether I have the cos graph. It happens every 90 degrees. The other thing I need to know is I need to memorize that that means 0, 90, 180, 270, 360, etc. Okay, that's every 90 if you didn't figure that out. Okay, the other thing is make sure that you memorize, in other words, know this for sure, that sine always starts in the middle. Okay, and we call that middle line the baseline or reference line, and it always goes up. Okay, so in typically, sine starts in the middle and goes up, and cosine starts at the highest and then obviously has to come down. Okay, so make sure that you have that piece, those pieces of information. Okay, so for today, those are true. When we go shift things left and right, obviously, things are going to change a little bit for us. Okay, so vertical displacement. This is what the equation would look like. It would have our y equals sine x plus a number or minus a number, and the same thing for cos. Now, it's not so important that it's a letter D here. It's the location of that letter D. So it is after the sine that we have that. Okay, and so what's really happening here is that D moves the middle of the middle of the graph, so that the x-axis no longer is the middle. Okay, the middle of the graph will be the value of that D, and we call it the baseline, or as I said, the reference line. It's the middle of the graph. Depending again on what textbook you use, some call it a reference line, some call it a baseline. That part's not important either, as long as that you understand that becomes the middle of our graph. Okay, so what's happening here is our graph is just either moving the whole thing up or moving the whole thing down. Okay, so that's what we're looking at. So let's go and try an example here. Okay, so, oh, it looks like that stayed there for a minute for some reason. Now, what I have here is it's asking us to graph the following: y equals cos x minus 1. Now, notice I have little numbers here, and that is because this is how I actually graph it. Okay, I look at the end first, and I can see that the end is, in this case, says -1. So I'm going to draw a dotted line at -1. Now, what I do is, usually when I graph these, is I just actually do it on, I don't even use graph paper. I just use my line paper, because my lines then become, for the y is important, and then I just put some ticks. So that's the first thing that I'm going to do, is I have to, first of all, add some information to my axes. Okay, so the first thing I'm going to do, obviously, I have x and y already labeled, but I do not have any numbers there. So we're going to start with, as soon as my pen starts moving around on me, in a second, just hold on a minute and I'll see if I can readjust. Okay, now hopefully it will work for me. Well, not right there. That's not what I wanted. And it's still going around and around. And that's not me that's doing it. I'm holding my hands steady. So it means that it is the mouse's turn to actually do this. So here is 1. Here's 2. We know that this would be -1, -2. Now, normally I wouldn't label my x-axis until I've checked everything else out, but I know that it's not being changed. So we've said every 90, so I'm supposed to 90, 180. Okay, so what I've done is I finished labeling this, and I could actually go also into the negative zone. We talked about that in our previous lesson. So now what we're going to do is we're going to go back so we have everything labeled on our axis. So the first thing that we look at is the number 1, so do a dotted line. So one of the beautiful powers of this is we can make a dotted line. Now obviously I'm going to use a color because I can. So I'm going to use purple just because I want to use purple. So I actually have a dotted line that goes across there, and that becomes the middle of my graph. Okay, the next thing that I look at is what's in front of my coarser sign. In this case, well, I don't see anything, but I know that actually there is a number 1. So that means I'm going to draw a dotted line 1 unit up and 1 unit down from my middle line. Now you're saying, why would you do that? Well, the reason I'm doing that is because my graph will fit between those dotted lines. Okay, the next thing I look at is coast. Coast starts at the highest spot. So in this case, the highest spot would be here at 0, 0. So what I do is I treat it like a ping pong ball. You heard me say that before, in the sense that I start at the highest point, and every time I go across a dotted line, and at every 90, I put another little ping pong ball. And so then I keep going down. I'm down as far as I can. So I got to ping pong back up and then back down and then back up. And so that's really how it's done. It's actually very, very quick and very, very efficient. Okay, so all I need to do now is draw a smooth curve, and we'll see how well I do on this with my mouse. Actually pretty good. And back down again, and remember we have put arrows because the graph does continue because it's periodic. Okay, so it's actually quite that simple. Okay, so I start looking at the end, put a dotted line there, that becomes the middle of my graph. I look in front to see what I have. In this case it's 1, so I put a dotted line 1 above and 1 below my baseline or reference line. I check to see whether I have coast or sign. Coast starts in the highest spot, so that's where I start, and then I treat it like a ping pong ball. All right, now the next thing we're going to look at is what we call amplitude. Now amplitude has to do, remember, is half the vertical distance. Okay, so our graph is half the vertical distance. And so what we're going to do now is we're going to change our amplitude. Now, the way we change it is by putting a number in front of sine or cosine to do that. Okay, so the amplitude of y equals cos x and y equals sine x is 1. But when we multiply these functions by a number, such as a, it changes our amplitude, and that's not an LAL, that's an absolute value sign. So the important x values do not change. So they still happen at 90, 180, 270, 360, 450, 540, and on and on and on. So, however, the way I do it is exact same way. So now I'm going to put some numbers on my y-axis, and I'm just going to pause the video for you while I finish that so it doesn't take up more of your time while you watch me write. Okay, so you can see I have the y and the x-axis labeled. So again, we start at the end. There's nothing there, so that means my middle line is my x-axis. Now, often when it's just the x-axis, I leave it alone and I don't touch it. However, in this case, I will. I think I'm going to make it a little more dashy than I did with the last one. And we'll do this one in green. Okay, so this is my reference line, which you cannot see, so I need to make it thicker. Okay, obviously you can see that one. Okay, Then I look at what's in front. What's in front is 3, so it means I go up 3 units and I go down 3 units, right? Then I look to see whether I have sine or cos. I have sine. Sine starts in the middle, so that means that I am going to start in the middle and go up. So every time I touch a dotted line and it crosses with the 90, I put a ping pong. And I go down, it ping pongs back up, back down. Okay, so it just keeps on going and going. And again, all we need to do then is to draw a nice smooth curve through it, and we are finished. It's that simple. All right, now you're saying it can't be quite that simple, Mrs. Broadhagen. Well, in some ways it can. Let's look at another one. Okay, so now in this case, we're going to combine an amplitude and vertical displacement. Okay, so these are the steps that I go through when I do it. So the first step that I do is I draw a dotted line at the baseline of vertical displacement. I draw dotted lines from the baseline as many units up as the amplitude, the new amplitude. I remember that sine starts at the baseline and usually goes up. Now, where it would go down is if I put a negative number there, by the way. And cos usually starts at the highest point unless I put a negative in front, so it would start at the lowest. And the points act like a ping pong ball. Every time the ball intersects with the dotted line and the important x values, I add a point. And finally, I join the points with a smooth curve. So we have another example. And with this example, what we're going to do is, again, we're going to follow those steps. The first step says dotted line at -1. Well, first of all, before I do that, I have to label my axes with their scale. If you don't do the scale, you don't get the marks. Okay, so I have mine labeled. So a dotted line at -1. And I think I will keep blue. Okay, my amplitude, I look at the front and it says that it is +2, so I'm going to go up 2 and down 2. So again, if I draw a dotted line. Now, are there other ways that you can do this? Yes, there are. However, this is the fastest way to actually draw them. And finally, I look to see whether I have sine or cos. In this case, I have a cos. Cos starts at the highest point unless I have a negative in front. And I don't, so I start at the highest and I'm my ping pong ball for every one of those. And if you notice, I do have some other dots here because it is periodic and goes on and on and on. And finally, nice smooth curve as best as I can. I missed a few of those points, but not too bad. Okay, you can see it still looks like a cos graph. The only difference being is it's been moved down and it's a little bit taller. So what you could do is if I decided to create the original, and I'll just show you very quickly what the original would look like. The original one would look like this. Okay, so once I put the original there, then it's much easier for you to see that something really has happened. Now I'm going to stop the video and I have 2 more examples and then you can have fun doing it yourself.